In this video, I am going to explain about the refractive index of a medium. Refractive index of a medium. Right? So now, the question is, how is the refractive index of a medium related to the speed of light? Okay, now obtain an expression for refractive index of a medium with respect to another medium. Okay, in terms of the speed of light in these two medium. Okay. So first of all, let me explain you now again how is the reflective index of a medium related to light. It is to the speed of light. So it is like this. Just I am showing you. So did you follow the question? Question is, how is the reflective index of a medium related to the speed of light? And the answer is this. Answer is this. It is So we have n is equal to c by v. It is c by v. So where c is the velocity. C is the velocity of light in vacuum and v is the velocity of light in the given medium Okay, so this is n is equal to this c by v. It is just, you can show here now. You can see this is n is equal to c by v. It is actually n represents the refractive index of a medium. Okay, refractive index of a medium. Okay. And one more thing here, when the refractive index of a medium is compared with the speed of light in vacuum, then that is known as absolute refractive index or simply refractive index. Is correct. Now the second part is that, so we have to obtain an expression for refractive index of a medium with respect to another medium in terms of speed of light in these two media. Right? So we have to obtain an expression for this. So just I am showing you how to get an expression here. So we have n1 is equal to c by v1 and n2 refractive index is equal to c by v2. It is okay, and therefore when we combine here, after combination we get n1 by 2 means it is n2 by n1 is equal to, this is c by v1 divided by c by v2, and in the end we get v1 by v2. So this is this. see this. So see here now, like yeah. So first one, this one is the refractive index of medium of the first medium with respect to the vacuum, and second equation, this one is the refractive index of a medium with respect to the vacuum. This is of first one and this is of the second medium. So when we combine together these two together now, like yeah, so we get now refractive index of the medium 2, okay, with respect to 1, okay, refractive index. See here now. So the refractive index of medium 1 with respect to the refractive index of medium 2, okay, is this one. So V1 by V2 it is here. So speed of light in the first medium divided the speed of light in the second medium. Right? One thing just see here now, like here, whenever we have to find the refractive index of a medium, that is written in the denominator, and when we compare that medium with the first one, then we write the speed of light in the numerator. So V1 by V2, so this is the answer. Okay, so refractive index of medium 1 with respect to the refractive index of medium 2 is this, right? Yeah. So now there is another question. Okay, refractive index of diamond with respect to glass is 1.6. Okay, refractive index of diamond with respect to glass is 1.6, and the absolute refractive index of glass is 1.5. Okay, do you know what is absolute refractive index? Absolute refractive index means when a refractive index of a medium is compared with the with the vacuum. Okay, with the vacuum. So now the question is find out the absolute refractive index of diamond. It is diamond. Okay, you have to find the absolute refractive index of diamond means this refractive index of diamond which is as compared to the vacuum. So this is the solution I am just showing you here now. Okay, the refractive index of diamond with respect to respect to glass is given here now. Okay, with respect to glass, this is G. This is G. This is G. This is G. See, this is the refractive index of glass. The first one with respect to diamond. Okay, it is 1.6 given, and second we have been given the refractive index of glass 1.5, and to find the refractive index of diamond you have to find. So, okay, to find the absolute refractive index of diamond you have to find. So now look at the solution here now. Okay, this is so refractive index of glass with respect to diamond is written as refractive index of diamond divided by the refractive index of glass. Okay, and the refractive index of glass with respect to diamond is given 1.6. So this is 1.6. This 1.6 is equal to refractive index of diamond divided by 1.5, because the refractive index of glass is given 1.5. So after calculations means refractive index of this diamond is equal to 1.6 into 1.5. So that is 2.40. So this is the refractive index of the diamond, or you can say the absolute refractive index of diamond. Okay, absolute refractive index of diamond. This is so okay. There's one more question about the apparent death. Okay, the question is A water tank appears 1.5 meter deep. A water tank that appears 1.5 meter deep it is here now. What is the actual depth? Okay, actual depth. This is not the actual depth. Whatever appears is not the actual depth. Okay, the actual depth is something different it is here now. So give a refractive index of water with respect to air. Okay, given that the refractive index of water with respect to air is 4 by 3, so you have to find the actual depth. Okay, okay. So let me tell you here now. Okay, children, the tank, the water tank that appears okay to be a bit shallow, it is here. That is not the actual depth. Okay, whatever it looks here, and so the actual depth of water in the tank is more than what it appears. It's okay, because the water, the depth, okay, the apparent depth, okay, comes up. It is, if this is the okay, this is the floor of the tank, it is here, so apparent depth will be okay a little bit up, it is here now. So here the apparent depth is given 1.5 meters. So you have to find the actual depth of okay water in the tank. And the second, what you have been given, we have given that the refractive index of water with respect to air is 4 by 3 is given. So see here, this solution here now. So this is refractive index is equal to the real depth, this is the real depth, this is the real depth divided by the depth of the actual depth. This is real depth by actual depth, by actual depth it is. So okay, that is the refractive index. So refractive index is also found in this way, real depth x divided by actual depth y here now. So what is y here? Y will be n into y, x is equal to n into y. So n, the value of n is given here now. So this is the value of n is how much here is given? It is given 4 by 3, it is given 4 by 3. And the y, the value, the apparent depth is given 1.5. So after multiplication these two together, so okay, the actual depth comes to be 2 meter. It is, see here, the 2 meter depth appears 1.5 meters. Okay, the apparent depth is 1.5 meter, but the actual depth is okay, it is 2 meter. It is correct. So okay, now one more question related to this apparent depth. The question is, if 1.5 meter were actual depth, 1.5 meter actual depth of water, then what is the apparent depth it is here? It is given, okay, it's been given that the refractive index of water is okay 4 by 3. So okay, 4 by 3. So see the solution here. If n actual depth by the apparent depth is okay. Actual depth by apparent depth. So it is given here now. So yeah, then it is okay, n is equal to it is x by y, you can say here, or y is equal to how much here, x by n it is, and x is given here 1.5. It's okay, and n is given here 4 by 3, it is given, therefore it comes to be 1.1 meter. So this is the answer, 1.1 meter is the answer.